This is AMC 8, 2024, and the questions from Art of Problem Solving. So let's start from the problem 1. What is the ones digit of, So what is the ones digit of this operation? So we can think about only the last digit. So here from 2 we subtract 2, so now 0, minus 2, now 8, minus 2, now 6, minus 2, now 4, minus 2, now 2. Or actually, if we add them together like this, the last digit, 5, is 0. So 2 minus 0, so again 2. And problem 2, decimal form. So now this is 4, this is for 10, 2, 5, 2.5. And this is 104, 0.04. So when we add them together, 6, like 2, 4 plus 2.5 plus 0.04, so 6.54. And number 3, first squares of side 4, 7, 9, and 10. So now what is the area of a visible gray region? Okay, so now the largest one is 10 times 10, so 100, minus, let me just write, 10 squared minus 9 squared, which is this part, plus 7 squared minus 4 squared. So now when we have this, actually this calculation is not difficult, but just to make it easier, I'll use this factor formula, like a 10 plus 9, 10 minus 9, plus 7 plus 4, 7 minus 4. So the first one is 19 times 1, which is 19. Second one is 11 times 3, which is 33. So 40, 52. Yunji added all the integers from 1 to 9. She mistakenly left out the number. Turned out to be a square number. Okay, so if you remember, the sum of all digits from 1 to all numbers, the integers from 1 to 10 is 55. You can use this quite a lot, so it's better to remember it. So this is 1 to 10. But here it says 1 to 9, so maybe it should be 45. But mistakenly left out a number. So actually we missed one number. But her sum turned out to be a square number. So after we calculating like mistakenly, it can be like square number, which is like 36, 25, 16, something like that. But here 9, here 20. So already this is not the integer between 1 to 9. So we left out the number 9. Alia rolls 2 standard 6-sided dice. Product of 2 number rolled is multiple of 6. Okay. So multiple of 6 with 2 6-sided dice. We can make 6 or 12 or 18, 24, 30, 36. 36 is 6 by 6. Let's say it like this. And 36 by 5, 5 by 6. So 6 by 4 only. We cannot make any other 24. 18, 6 by 3. Because we don't have any 9, something like that. So this is a 3 by 4 or 6 by 2. 6 we have more, 1 by 6, 2 by 3. Oh, that's it. So now we have sum of 7, 5, 7, 8, 9, 10, 11, 12. So what we cannot have, which is 6. Problem 6. So from here, Sergey skated around an ice rink, gliding along different paths, P, Q, R, S. The gray lines. Okay, so shortest to longest. So shortest, we can compare P and R. But all the same, but here only this is 2 line, while this is like the circumference of the semicircle, 2 semicircles. But here, because this is the line inside of the circle, so actually the line is the shorter, so R is the shortest. And P between Q and S. So we don't need to compare the same part. So now we need to think about this and this. So maybe we can make it better like this and this. So if we compare these 2 lines, it's easy to think S is shorter than Q. So like this, R, P, S, Q. So number 7, 3x7 rectangle covered without overlapped, 3 shapes of tiles, 2, 2, 1, 4, 1 by 1. So minimum possible number 1 by 1 tiles used. So which means we need to use as many as tiles of 2 by 2 and 1 by 4. So 2 by 2, let's say 1, 2, 3. That's all. And 4 by 1, 1. That's all. Because now here is a 7 and 3. So we cannot make it, we cannot put more 1 by 4 here, more 2 by 2. So now we have a 1, 2, 3, 4, 5. On Monday, Taye has $2 every day, $3 or doubles the amount of money. Okay, so he started from 2, and every day, maybe like plus 3 or times 2, something like this. So on the previous day, how many different dollar amount could you have on Thursday? Okay, so this is only 3 days. So this is not a lot, so we can think about it. So he started from 2. So let's say plus 3, this is X, this is Y. So from here, so this is Monday, Tuesday, Wednesday, Thursday. So plus 3, plus 3, plus 3. And plus 3. So this is a little bit. So let me make the arrangement first, not to get confused. So X, 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 Y, X, Y, X, X, Y, Y. So likewise, Y, 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 X, and Y, X, Y, and Y, X, X. So this is what we can make the arrangement out of these 3. Yeah, because we can make a 2 and 2 and 2. So let's think about it. So from here, the first one, out of 2. So let me start from here. So Y, 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 2, 2, 2. So 8 times 16. 8 and plus 3, 11. 4, 7, double. Double, plus 6, 10. So already we have 4. And X, 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 2, 2, 2. So we have 6 more, which is 8. We have 4 more, which is 6 times 12 times 2, and 4, 8, 2, and 4, 8, and 16. So how many? 1, 2, 3, 4, 5, 6 different dollars we can have. So this is 6. So this is not just a simple counting. I mean, you need to go through all this. Maybe that's why it gives you only 3 days. All the marbles in Maria's collections are red, green, blue. Half as many red marbles as green marbles. So red marbles is half of green marble. And twice as many blue marbles as green marble. So blue is 2, green. Total number of marbles in Maria's collection. So all G, B. All G, B. So all together, 7 G. So you know, G should be the even number, and the sum should be the integer of 7. So no, I mean multiple of 7. So multiple of 7 only here, 28. In January 1980, Mauna Loa observation record carbon, okay. So it was 338 ppm. Over the years, the CO2 reading has increased about 1.515 each day. Okay. So 2030. So she started from 1980. So here it was 338. In 1981, it was 338 plus 1.515. 1982, 338 plus 1515 times 2. Blah, blah, blah. So now we are 2030. So we are in like after 50 years. So 338 plus 1.515 times 50. So 75 of 75. So here, this is 75.75. So plus 338, 3, 1, 4, 414. And let's go to the next one. Coordinate here. This is ABC is like this. Area is 12. What is the value of y? So here, when we see this obtuse triangle, we know how to have the height here. This height is y minus 7. Always the difference is like subtraction from larger number, like the smaller number. So this is y minus 7, which is the height, and this is 6. So now the area is half 6, 7 y minus 7. Sorry, this is 12. So 3 and 4, so y is 11. Problem 12. Rohan keeps a total of 90 guppies in 4 fish tanks. One more guppy, second tank. Okay. So second tank, T2 has one more. And third tank, second tank, 2 more. First tank, 3 more. How many guppies are in the first tank? So when we add them together, those are 90 guppies. T1, T2, T3, T4 are 90. So when I add them together here, I can eliminate, no, actually in this case it's better to express with one variable. So now we want to know the first tank. So T3 is T4 minus 3. T2, T3 minus 2, which is T4 minus 3 and minus 2, which is 5. T1 is T2 minus 1, so T1 can be T4 minus 5 minus 1, so this is minus 6. So when I add them together, 4T4 becomes 14, 104. So T4 is 26. And so when you have like many variables like this, actually we can calculate only one variable only. So when you have like these different variables, we need to find a way to reduce it to make it only one variable. Number 13. Bunny hopping up and down and 6 times, end up back on the ground. So eventually he need to make 3 ups and 3 downs to come back on the ground. And we can guess, because this is one way, I mean the start should be up and the end should be down. So he will make 6 up and downs, but start is U and the last is D. So now we have 2 U's and 2 D's, and we can make an arrangement. So for example, U, U, D, D. U, D, U, D. U, D, D, U. Like this. And same D, D, U, U. D, U, D, U. D, U, U, D. Like this. But out of this cannot be the answer because 1 up and 2 down, he cannot go lower than ground level. So we have only 5. Problem 14. This is the one-way routes connecting towns like this, and distance A to Z, shortest distance. Okay, so let's see. From C, like for here to arrive Z, what is the shortest? So at this moment, this is the shortest. Let's say from M, or so this is 23, and let me. That is 37. This is 8 and 17. Oh, okay. So now let's think about it. But actually from here to here is 33. So, no, but actually like this is 32. Even shorter. Oh, but like here, so yeah, this is confusing because of the drawing is not like scaled. Okay, so let's go to in the middle of somewhere. Let's say, for example, we need to decide go through M or Y, for example. So in this case, we can make 7 and 6 and 5 and 10, let's say. This is 32. Because this is also 32. And like this is already 31. But like here, for example, this is even shorter, 7 and 11, 18, 28. Oh! Anyway, because we have options, so if we find the smallest number in the option, then that's the answer. So let the letters fly, bug, distinct digit. Oh, okay, all distinct digit. Fly is the greatest number of satisfies the equation. Fly and bug. So 8 times fly becomes a bug. So fly becomes times 8 becomes bug. I think from here, because it should be repeated like here, so F should be 1. Because F is not 1, this cannot be 3 digit. You know what I mean? Because 2 times 8 already becomes 16, so we need another one here. So anyway, F equals 1. And so B becomes 8 or 9, we don't know yet. And Y cannot be 0, because in that case G should be 0. But it says distinct digit, so it cannot be 0. So let's say Y, but this, the B already 8, endless it is 8. So if we have like 2 high number from the multiple like product of L and 8, we cannot have this number come over like more than 1 or 1, more than 1. So L should be 2 here. If we did 3 already, 3 times 8 becomes 24. Or actually L becomes 0, 2. I don't know yet. Yeah, let's make it like this. L becomes a 2 or 0. And Y becomes I don't know, let's say 7. Oh, if I make it 107 there, let's say 127 or 107, let's say 7, 8, 6, 5. If it is 0, 0, 8, 0, so this becomes 5. 1, 8 becomes 8. So we don't have any, this is all distinct number. So this can be the answer. So 107 plus 8, 5, 6. Or let's see, 127, whether it can be the answer too. So 2 times 8 becomes, because it has a 5 there. So now we have 1. So we have repeated here. So this cannot be the answer. So this is the one. But you know, I just guessed this number 7. I don't know how I reach the number. Yeah, I just want to avoid like the number which is an end of 0 or 2 when it multiply to 8. So I try just 7, and now we have the answer. So now the last digit fly and bug. Oh, but last digit should be 3, but it's not. Greatest number. So this is just one of the cases, not greatest number. Greatest number, okay. So let's say 9. Yeah, somebody should have 9. But this is 2. It cannot be 9. 8, 4, 2. No, this cannot be. Then it's 7 again. No. 6. No, because already 4. Yeah, because it have this leftover, which is 2. So 6 cannot be. So 5. No. 4. No. 3. Yeah, now we have. So the number is 123 plus 984, which is largest number for fly, 123. So 7, 0. Maybe this is the answer. So yeah, the beginning I didn't recognize that I need to find the greatest number. So actually I was confused because I thought I found a little bit too easy, like by guessing. So at that time I thought, if I can find like this, somebody may find the other number and make many maybe like a different result. Then yeah, but actually there was the number 16. Enters the number from 1 to 18 into the cells 9 by 9 grid in some order. Product of the numbers in each row and column. Product divisible by 3. So now we have multiple of 3, like 27 multiple of 3 in these numbers, because 81 is 3 times 27. So for example, now we have 9 by 9, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say 9 by 9. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is 9 by 9. So for example, if I arrange all those multiple of 3s here. Oh, this is still. So here, let's say 1, 2, 3. Let's put them together. Then we have these 3 columns, but all these 9 rows are also the product of multiple of 3. So in this case, we have 12 rows and columns whose products are multiple of 3. But because this is the largest number in the option, so let's think about something else. Totally different way. Let's not spread them around. Let's put them together somewhere, not in the center necessarily, but let's put it in the center. So 27. So we can put them 5 by 5, 1, 2, 3, 4, 5. Let's say, so all together here, we still have another 2. So in this case, here, 5, and here, 5, which is 10, but we still have another 2. So for example, if I put them here, and here, let's say, then we need to add another 2. So let's say we can add here and here. Then we add only another 1. So plus 1, 11. I think we cannot make it less than this because this is the densest way. This is most dense way to put them together. So this can be the one. 17. Chess king is said to attack. All square 1 step away from it. Okay. So suppose white and black kings are placed on different squares of 3 by 3. So among here, one square has white king and another one has the black king. And so that they do not attack each other. So for example, white one here and black one here, they cannot attack for the next turn. So which means they need to be away. Okay, so let's think about it. Let me just think about white. Just to think about in the center of the white. So for example, white is here, then black should be here. But white cannot be 4 corners. So this can be 20 different cases. So if white is at the corner, we can make 20 different positions between white and black kings. But if white stays here, not corner, on the line, but at the boundary line, then black should be here, so 3. So 3 times 4 again, because white can be 4 different boundary, the center of the boundaries. White cannot be here, because in this case, yeah, we cannot attack each other. We can attack each other. So this is the 20 plus 12, which is 32. So this is how white. But I think this is what we can think about. I mean, this is all. Because white, I said at the beginning, I need to think about white case and black case and do something like that. But if white here, then black is already here, 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 here. So this is the case, whether black is at the corner or at the center of the line. So we don't need to think about black's special position. So I think this is 32. Problem 18. 3 concentric circles are centered at O, 1, 2, 3. B and C. 2 smaller circles are shaded. So portion of the region between 2 larger circles bounded by central angle A, B, O, C. So here, so now this is the one. Okay. So the shaded and unshaded regions are equal in areas. So BOC, we don't know what is BOC. Okay. So let's see. Then I'll just make it easier way. So now this is 3. So we know the sum of shaded and unshaded regions area, which is 9 pi. So 9 pi over 2 is the shaded region. So I just do it like this. I don't want to calculate shaded and unshaded like individually. I'll just do it like this. So here and shaded, let's say here first. Then 4 pi minus 1 pi plus. So now we don't know the central angle. Let's call it x. So now we need to calculate here. 9 pi times x over 360 minus 4 pi times x over 360, like this. So this is 3 pi. So 3 pi over 2 becomes x over 360 times 5 pi. So pi 180, 36. X becomes 108. And number 19. Jordan owns 15 pairs of sneakers. 3/5 of pairs are red and rest are white. So we don't, 15. So this is red and white. 2/5 times 15. 2/3 of the pairs are high top, and high top 2/3, and low top 1/3. Red high top sneakers make up a fraction of collection. What is the least possible value of this fraction? Okay. So red and high, like this. So now, yeah, actually, do I need to think about, I don't need to calculate this one, I think, because we know the probability, probability of red is already 3/5. Probability of high top becomes 2/3. So if we use this Venn diagram here, red and high top, we can think about this one. So here, the least possible value of this fraction, least possible value means least intersection. So as little as possible, which means red and high top, the union becomes 1. So if you remember the formula to find the union, red union high top becomes red plus high top minus red and high top. So now 1 equals 3/5 plus 2/3 minus x, let's say x. So here 15, 9, this is 9, 10, 19, so x is 4/15, which is 3. C. We need to find equilateral triangle who contains P as a vertex. So let's say, for me, this is the very easiest triangle I can find. So for example, like this one, when P is this side, I mean, not exactly here, but I can think about here too, for example. So this is 2 triangle there, for example. I think because from P we can make like these 3 diagonals there, and each of the diagonals make 2 different triangle like this and like this, for example. And no, I think this is easier to calculate, counting. So like this again, and this is 3. So what I found now, So from P, we have diagonal like this, 3 diagonals here. So out of 3, we can make the triangle with 2 diagonals here. So PV and PT one, PR and PV another one, PT and PR another one. So I think out of that, we can make 3 different equilateral triangles here. Can we find another like because this, for example, if I find like this, I cannot make equilateral triangle. I mean, I can make right triangle, but this is not equilateral. So I think this is 3 because I can consider only diagonals. And if I consider P2U, for example, it also not the equilateral it's not good idea to connect from P to U because we cannot compose an equilateral triangle with that diagonal. Number 21, group of frog living in a tree. Turns green, shade, and turns yellow in the sun. Okay, so the ratio of green to yellow frog, let's say 3x and 1x initially. Then 3 green frogs move to the sunny side. So here this is green and yellow. So 3x minus 3, here 1x plus 3. And 5 yellow move to here. Oh, 5 yellow. To the shady side. And now the ratio of 4 to 1. Okay, so 3x plus 2, x minus 2 is 4 to 1. So 4x minus 8 becomes 3x plus 2. X becomes 10. So now x becomes 10. So yellow frog. Now how many yellow frog? Difference. Oh, sorry. So difference between here to here, 3x minus 2x plus 4. So 24. So problem 22. So roll of the tape 4 inches in diameter and wrapped around the ring 2 inches in diameter. Cross section. Okay, so here is 1 and 1, altogether 4. So this tape is 0.015 inches thick. So maybe we can consider how many layers we have there. So 15, 1000. Maybe 66 or 67. 66.7, something like this. So let's say 66 or 67. So now we can consider here. The last row will be same like here, and largest row is here. I think this, because now we cannot use any calculator, so we cannot make any complex equations to solve. So the smallest one is 4 inches, 4 pi inches, the circumference. The largest one is, 2 pi. 4 pi. Because whenever we roll out like one layer by layer, they could be very similar because this is almost like a circumference, and 0.015 inches is quite thin. So we can, and anyway, this is circle and all circles are similar. So all layers on here are similar. Then we can just make it easy from 2 to 4, like 2 pi to 4 pi. Let's just make it quick. All of them 3 pi's. So because this is average, so 3 pi times 67, let's say. Then pi becomes, let's say, 3. Then 9. 603. So this may be 600. Because anyway, we cannot use any calculator, and this it doesn't ask us like very accurate answers because nearest 100 inches is not. So like this, we can calculate it with like one significant level or something like that. And problem 23. Rodrigo has very large sheet of paper and drew a line segment connected 0 to, okay, like this. And whenever it passes the, like the grid, cross, like go through, then he made a shadow like this, colored. So now we have from, let's say, from 2000 to 3000 to 5000 to 8000. So this one is 3000 and 5000, something like that. So the slope is 5/2. So now we may 5/2, 5/3, sorry. So we can make 5/3. 5/3 slope looks like this. Is it? So 1, 2, 3, 4, 5. So now whenever we make 5/3, which is a 5y grid and 3x grid, then we can color here 1, 2, 3, 4, 5, 6 colored. 1, 2, 3, 4, 5. Yeah. So now we have here, this is 3000, but we make like 3 to 5. So if we set this 1 unit, then we have 10 units there because this is one length already 3. So 3000 has 10 lengths, 10 units. So 10 units here, also actually 10 units, because we have a 5000 difference here, and our 1 unit has, oh no, I made mistake, this was 4, sorry. So 1, 2, 3, 4, 5. So this one we can like this, 1, 2, 3, 4, 5, 6, 7. I think like this, because I expand this picture too much, so I cannot make a thinner pen. So this is too thick. So whenever I make 1 unit, in 1 unit, I need to color 7 squares. 1, 2, 3, 4, 5, 6, 7. So altogether, I need to color 7000 squares. Number 24. Zin has made a piece of stainless glass like this, 12, and what is the value of H? The artwork has area 183. Okay. So let's say like this. So this is 8. Let's think about only here. So this is 8, and this is 8. This is 8 also, because this is already isosceles triangle. So the first only here, this is the area, this has the area of 16 times 8 half, 64. And here, because this is 12, again 24 times 12 times 1/2, 144. But the problem is we calculated this twice, this like intersection part. So we need to take one out. So that one, if it is 8 there, then again, because this is also the 45, which is right isosceles triangle. So this is 8 and 8. So 144 plus 64 minus 2h times 8 and half becomes 183. So 208 minus 183 becomes 80 squared. So this is 25. 8 becomes 5. And number 25. Small airplane has 4 rows and 3 seats. We have 8 passengers already on board, and married couple will come and want to sit together. So without considering the married couple, those 8 passengers may choose the seats out of 12. Like the first person comes in and select out of 12. Second person out of 11, blah, blah, blah. The last person right before the married couple will choose out of 5. And now we have 4 empty seats. This is a little bit, when we think the case straightforward, it's a little bit confusing, then we can consider the totally opposite side. So now I try to not to give any 2 adjacent seats to the couple. So for example, if we make seats like this, then we cannot make any 2 adjacent seats. So let's ask somebody to come and sit the first centered seat out of 8. So any person come and sit, then one of the person out of 8 may raise the hand, for example. So 8, 7, 6, 5. And now we occupy 4 seats, and now we have empty 8 seats. So out of 8 seats, so now we have 4 more passengers. So the 5th person comes up and see those 8 empty seats and decide which seats the person may sit. So again, 8, 7, 6, 5. And not only this arrangement, not to give the 2 adjacent seats, like this also. But we need to decide that this arrangement can be which row. So out of 4. So now we decide which row we can make this arrangement. But now, anyway, we have this 5 occupied first. So 8, 7, 6, 5, 4. And now we have, but we need to empty here, not to make the repetition with the previous case. So now we have 6 empty seats and 3 people. So 6, 5, 4. So another one is like this. So we need to determine which seats, which rows will be this arrangement or that arrangement. So out of 4, we need to decide the 2 rows. So out of 4, we need to decide the 2, but we don't think about the order. So this is like 6. And 1, 2, 3, 4, 5, 6, 8, 7, 6, 5, 4, 3. Times we have 4 seats. So 4, 3, yeah. Then we have 8 passengers already. Yeah. So now plus. So now let's make it another one like this. So here, arrangement yeah, we can choose this arrangement now to make it easier. 4, 8, 7, 6, 5, 4, 3, and 2. The last person can choose out of 2 again, which is empty seat. So now this is the last case. And we have 8 seats and 8 passengers. So we can just go through A7, 6, 5, 4, 3, 2, 1. So just to make calculation easier, so the first one, I can make 8, 7, 6, 5, 4, 3, 2, 4 here, 3, 2 here. So now we remains like this, which is 70. So 8, 7 until 2, and the first term remains 70. I'll just try to make everything like this. So this is so we have here 3 and 2. So now we have here 80 plus 3 and 2, and now we have another 2 here, and 6 and 6, 36. And now we have until here, we have 8 and 1. So like this. So we can cancel them out from 8 to 5. So we have denominator 12, 11, 10, 9. And numerator we have 4, 3, 2. And 150 and 45, 195. So 12. So 2, 5, 39, 3, 13. So now we have 33, 13 over 33. But we need to remember, we made this one like totally opposite side. So the final answer is, which is 20 over 33.